All right, guys. So it's come to my attention that maybe some of you guys don't really know how a maglev works. I actually didn't know how it worked when I first started building these. And I started building them doing the most basic maglev you can do. So I have this guy here. This is a Mendocino motor. And if you could see, it's being suspended by three magnets on each side. And then this guy just floats like right in the middle there. This is an example of a really good open, what I would call open maglev. This one's so good you can hold it upside down and it's not going to come out. This is the type of maglev that I did in the beginning. It's really simple. I made several of these. And as Jimmy DeResta says, the first one we go to school on. I actually used this guy to model the ones that I was making. And so basically you just get some plexiglass, put three magnets in with this cutout here, like that. You can see them here. And getting them, hold on a second, getting them in the right orientation, meaning north, south is very important. So here you can see that's north, and that's north. And it's the same thing on this side, north, north, north. It has to be the same. And then the external one here has to be south. The weird thing is that right inside this area here, even though this is a north pole, so it'll attach to that south pole here, this internal area here is actually the opposite of this. So if this is south, this is north. And so that really plays in when you're trying to, that really causes an issue when you're trying to do a closed maglev, which is what I'm going to show you a little bit now. So here's an example of a closed maglev. So I've got two magnets here, right? And two ring magnets here. And so this would be north, this would be south. But inside this area here is a north pole. So when you try to push this in, it's really hard to get it. It's pushing north against north. And we all know that like poles repel, opposite poles attract. So the key to a good maglev is you have to get it in there to a balance point. So it's really hard to push. Then it wants to break through and it wants to push this way. So a really good mag is you get it to the balance point and then you get it just a little bit past the balance point. So it wants to push this way up against the wall. And so now it's being held up against the wall. So I'll exaggerate it a little bit. So we'll say it like this, but actually it's more like this, where it's about 2 millimeters past that balance point where it's pushing in either direction. So here it wants to push this way. Once I go past, it wants to push this way. And it wants to push and sit up against the wall. And that has to happen on both ends of the maglev. This end and this end, right? So basically what you need to do is, after you've established that this is either a north or a south, and the end of this ring set is the opposite of this, but the internal area inside here is going to be the same pole as the end of this main rotor shaft. So you have to push past it. Once you do that, you can't, so it's pushing on both ends like this, right? So it's pushing on both ends like this. What you can't do is have it push and be up against this back wall here and up against this back wall. It can only be on one end. If you hear this, listen to this. You hear that sound? That's because I've set it up in such a way where this is really only pushing against this back wall here, and it's floating over here. It can still touch this wall, but it's not pressing against it. So I hope that cleared up a few things. Something else I was thinking about, and I thought about this a while ago, and some other commenters have mentioned it, is instead of having a wall here like this, what if I had a magnet on the end here and then a magnet on the wall here, opposing, like poles, so they would oppose each other? Wouldn't that would make a really true, absolute frictionless maglev? The only problem is it's damn near impossible to do. The only reason this even exists like this is because it's being pressed up against this wall. And you're saying, well, you can just press it up against an opposing or a like magnet, and that should hold it in there. And in theory, if I got it so it was just going past this point here. So if I show you here, if I can get the camera to point right, just going past that. And then I have the like poles here, one here and one here. It should be able to hold it there, right? And if I did it on both sides, the only problem is getting that balancing act would be damn near impossible. And even if I could, as soon as it started spinning, it would kick off like this. You see what I'm saying? There's nothing holding it there. It would kick off like this or kick off like that. Because I thought about doing that with my vertical maglev. That guy over there, that big brown guy over there in the vertical stand, which I don't know where that's at. It's somewhere. But there's some of my other open-ended maglevs. Anyway, I thought about doing that, and it's just not going to work. So I'm going to stick with this guy here, and he now starts automatically, is nice and just hums. So one of the things I was thinking of is, because this is hardened stainless steel, and what I have back here is aluminum. That was the only metal I had that was non-ferrous. Let me turn it off. That was the only metal I had that was non-ferrous, and it's not good. Tomorrow I have some 304 stainless steel plates coming in, and I'm going to replace the aluminum. But this hardened stainless steel has a point to it, and it's drilling into that aluminum. And I'm wondering if it's causing any heat buildup on the end there. I don't think it's causing anything that's, I'm sure over time it would. But this is a perfect setup now. So now what I'm going to do is, I've also got some new 304 stainless steel coming in. And this is a really good rotor head. I don't know if this one has a sleeve on it. I have sleeves for this. I'm also going to make a sleeve for that, because the last thing I wanted for these bars come flying out. So I have a sleeve that I printed out for this one. I have to print, it's over there. I'm going to print out one for this one. I'm going to change out this guy. This was the 304 steel rod that I actually painstakingly grinded down. I think I did a really good job, grinded down so that there was a transition from fat to thin. This one, the transition is all done with 3D printed parts. And I've tried that before. I've tried that before with Maglevs with limited success. This one's been a complete success. Of course, I don't know over a long period of time. I don't know how well it's going to hold up, but I don't need it over a long period of time. I just need it to work. Anyway, I wanted to show you the difference between this type of maglev. This is a really good one. I've never gotten my open maglevs to work this good. It's a Mendocino. Let me see if I can turn this on and show you how this guy works. He's really cool. Come on. There you go. Yeah, so those are all little solar cells on there, and they're all connected to coils, which are activated on and off with this permanent magnet underneath. The permanent magnet doesn't go on and off, but the coils do. I had gotten this because I liked it, but I also wanted to see how the maglev was set up as far as the distance was, and I was never able to copy this exact. This is a really good model, but I was able to get it to work good enough. In fact, that big brown beast over there, not the one on the left, but the one on the right, used to be a maglev, but I wanted to get it down because when I was building this type of maglev, the open maglev, I was having some success. It was limited, but then I kind of noticed the way Sky was doing his, and that kind of scared me. I didn't think I could do it, and then I realized, wait a minute, I can do that. But one of the issues I was doing was my magnets on there were too small. So the gap between this inner ring and this outer ring was way too big. It was more like this. Now the gap, I don't know if you could see, but the gap is damn near about 3 millimeters, which is really good. But it makes it 10 times harder to get it in there, to get it past that point. But that's about a good estimate of how much space you would need between these guys here, because, and also I was only doing one magnet and one ring, and I doubled it up to 2 and 2, which makes a really big difference. Anyway, I just wanted to show you guys that because I've seen a couple of comments. Let me see if I could fire this puppy up, and it auto starts almost all the time now. Let's see if we have any heat showing up over here. No, not really. No. Let me turn it off. All right, that's it for right now. But stay tuned, because as soon as that plate comes in, I'm going to change these guys out and get that hardened stainless steel plate in there. I know there's ways to harden aluminum. I looked it up. It didn't seem straightforward, but I've gone this far. I might as well go the rest of the way. And I'm not really fond of this rotor itself. I like this black one much better. Oh, it's a much cleaner design, cleaner setup. This red one was part of a 4-pole system. Anyway, stay tuned, guys. Ciao. So also, to go back to my earlier maglevs, you can see here, so I used carbon fiber rods because they're non-ferrous, non-magnetic with um, brass inserts inside of them. But I used 3D printing to mount, and you can see how small the magnets were back then. 3D printing to mount these magnets on here, and then ball bearings on the ends. And they were very successful, but these are not strong. They're not strong at all. These guys are really beefy, and they're printed at 100% infill, where I don't think I did that with these guys. And they're just not very strong. They would run really great for a short period of time. So I still like the ball bearing end versus the pointed end, although I'm growing fond of the pointed end right now. But I still like this. And when I build this guy out to mount in here, I'm going to, instead of having a point on the end there, I'm going to use the same 304, but instead of a point, I'm going to round this guy off just to see, so I can test the two. This one will be pointed, this one will be round. So like I said, I've got the plates coming in tomorrow. I love this coil. This is a beautiful coil. It's the nicest coil I've ever wound. Anyway, I've got the plates coming in tomorrow. It shouldn't be hard to cut them up into either strips or circles. I'm debating. I think I'm going to do it in strips. I did it in circles with the aluminum, and I actually, instead of trying to glue them, I screwed them in to the back of this plexiglass or acrylic back here, this support wall. And I think I'm going to do the same thing, but in a strip. I don't think I need it to be round. I don't think I have to go to that extra length. So I'll cut a strip that I think will work as far as width and length, drill some holes, which are going to be tricky. Drilling into stainless steel is a nightmare. I know there's ways that you can temper it so that it'll make it a little bit easier to drill. So I'm going to have to figure that out. I know there are ways to do it, but I don't want to temper it soft and have to retemper it hard again. So maybe yeah, I don't know. Yeah, it's going to be tricky to drill that stuff. I've tried drilling stainless steel before and it was bad. Anyway, stay tuned.